Have you ever wondered what invisible secrets drift just above our atmosphere? Back in 2024, a tiny celestial visitor briefly adopted our globe as its home, circling us for roughly 8 weeks.
This miniature companion essentially took a couple of scenic loops around our world before gracefully bowing out, knowing precisely when to end its cosmic stay. Slipping away from our gravitational embrace, it returned to its primary journey, tracing the immense fiery silhouette of our local star. Yet, what if I told you there is a hidden hitchhiker lurking out there right now? Scientists just uncovered a completely different stony Voyager that has been shadowing humanity not for a mere fraction of a year, but for 60 long years. This peculiar anomaly is an incredibly uncommon phenomenon, officially labeled by experts as a quasi-moon. So, what does that actually involve? Should we consider it humanity's spare orbital nightlight? Well, throw out any comparisons to that glowing silver orb responsible for our ocean tides and mythological tales, primarily because this celestial drifter does not actually loop around our world at all. Rather, it traces a massive path directly around the blazing sun. Yet its orbital rhythm perfectly mirrors our own yearly journey. Picture a fellow athlete running right beside you during a massive marathon, matching your every single footfall, stride for stride, without ever bumping shoulders. From down here on the surface, the cosmos appears incredibly peaceful. But that silent void is secretly a chaotic battlefield of invisible forces. Gigantic masses like our homeworld, the lunar surface, neighboring gas giants, and the blazing sun are locked in an endless, invisible game of gravitational tug-of-war. And those titanic forces heavily toss around the smaller debris scattered across the vacuum. Because of this violent dynamic, wandering space boulders rarely maintain such a perfectly synchronized choreography for very long. Usually, they wind up shoved onto entirely different paths, dragged violently into our atmosphere, or catapulted away into the freezing, empty darkness of the galaxy. Catching even a glimpse of a couple of these synchronized travelers at any given moment is an extraordinary stroke of astronomical luck. The cosmic tightrope is simply too unstable for the vast majority to walk. These fascinating stragglers are members of a broader astronomical class known as co-orbitals. Researchers actually categorize this entire family tree depending entirely on the unique ways they drift and sway alongside our planet's path through the void. Yet, contrasting sharply with our permanent, cratered guardian that has watched over humanity since the dawn of time, these transient wanderers are strictly temporary residents. A handful might ghost alongside our blue marble for a few dozen years. A rare few could pace us for hundreds of years, right up until the gravitational pull from a random passing body steals them away. Imagine a loyal puppy happily jogging at your side, only to completely abandon you the second it catches the scent of a barbecue 3 blocks over. Another mind-bending aspect of these phantom companions is their incredibly diminutive scale, as nearly all of them are no larger than a typical office building, or sometimes even smaller. Furthermore, they reflect virtually no sunlight, allowing them to brilliantly camouflage themselves against the dazzling backdrop of the Milky Way. Nevertheless, uncovering these invisible neighbors is an incredibly vital scientific endeavor. Tracking their behavior grants astrophysicists profound insights into the mechanics of tiny planetary neighbors and precisely how long our world's invisible leash can hold on to wandering cosmic debris. Because these synced travelers float relatively near to our doorstep compared to typical asteroid belts, physically launching probes to them would be phenomenally straightforward. In the distant future, humanity could literally utilize these convenient boulders as vital orbital gas stations or launch pads for traversing the deeper mysteries of the solar system. Unsurprisingly, our home has hosted a handful of these invisible groupies throughout history. Among the most celebrated is a rock designated 2016 H03, which scientists have beautifully dubbed humanity's constant companion. Spanning a mere 300 feet across, this tiny speck has somehow maintained lockstep with our world for almost 100 years. And brilliant minds predict it will happily continue tracking us for hundreds of years into the future. So, what is the story behind our universe's latest, freshly uncovered stowaway? The astronomical community officially christened this fresh mystery object as 2025 PN7. As touched upon earlier, This silent observer has quietly tracked our trajectory for 6 decades, and calculations suggest it will stick around for roughly another 68 years. For a sprawling chunk of modern history, it managed to entirely evade our most powerful telescopes, simply by being unbelievably microscopic on a cosmic scale. Measuring barely 62 feet in diameter, you could comfortably fit its entire mass onto a standard neighborhood bowling lane. That completely shatters any hope of stepping into your backyard and spotting it with your own eyes, no matter how powerful your consumer telescope might be. The origin tale of this pebble is completely shrouded in shadows, as researchers are still scratching their heads over what exactly the rock is made of. Currently, the absolute only piece of the puzzle we possess is the mathematical certainty of its flight path. A handful of these synchronized satellites are simply random space rubble that miraculously tumbled into an incredibly lucky orbital groove. However, deeper investigations suggest some of these stragglers might literally be shattered fragments blown off our very own lunar surface. Take, for example, a mesmerizing co-orbital known to the scientific community as Kamoa-Lewa. When starlight hits its surface, the resulting glare perfectly matches the spectral signature of the dusty samples astronauts famously bagged during the Apollo era. Due to this stunning similarity, many experts suspect we are looking at the ancient shrapnel of a colossal, prehistoric asteroid strike that violently scarred our real moon eons ago. Have you ever heard of the asteroid known as 2024 PT5? A fleeting little mini-moon that graced our night skies late last year. Chemical analysis revealed its exterior bore a striking resemblance to the dark volcanic rock found on our actual moon, strongly suggesting it was originally a chipped-off fragment of our own lunar companion. But here is the real mystery. How exactly do these bizarre quasi-moons manage such a delicate gravitational tightrope walk? The secret is that it is all a magnificent celestial mirage. Just like its counterparts, Asteroid PN7 is not genuinely orbiting our world at all. From our vantage point on the ground, the rock appears to be sketching carefree spirals right alongside our journey through space. Think of them as invisible cosmic doodles, where the rock somehow perfectly paces itself, never falling too far behind or rushing too far ahead. In the realm of astrophysics, experts refer to this synchronized dance as a one-to-one orbital resonance. Simply put, the asteroid completes exactly one massive circle around the Sun in the exact same time it takes Earth to do so. Which brings up a fascinating thought experiment. If these imitation moons are hovering right next door, why doesn't Earth just reel them in like fish on a hook? After all, they are relatively minuscule in size and appear to be brushing right past our cosmic backyard. The truth is, despite earning the label of near-Earth objects, these quasi-moons are vastly farther away than they seem. Our true faithful moon hangs in the night sky at a distance of roughly 239,000 miles. By contrast, these masquerading companions are soaring around the Sun from millions of miles away, completely out of reach of our planet's gravitational grip. Earth's true zone of influence is confined to an invisible boundary known as the Hill sphere, a specific region in the dark where the tug of our planet finally overpowers the massive gravitational anchor of the Sun. Picture Earth wrapped in an invisible magnetic bubble that stretches outwards for around 1 million miles in every direction. Anything wandering into this sphere gets captured, just like our actual moon. But cross that line outward, and the Sun ruthlessly steals control. That precise game of cosmic tug-of-war is what dictated the fate of 2024 PT5. For 2 fleeting months in 2024, it breached our Hill sphere, allowing Earth to snatch it up as a genuine, albeit temporary, satellite. The moment it was locked into our gravitational embrace, scientists officially crowned the tiny rock a mini-moon. However, given its diminutive size and blistering velocity through the void, it eventually pierced right back out through the edge of our bubble, where the Sun promptly dragged it back into the solar depths. Beyond the realm of quasi-moons and mini-moons, the universe presents us with another strange phenomenon: horseshoe orbiters. These peculiar fragments of rock remain relatively close to our neighborhood, but if you were watching from Earth, they appear to speed up in front of us, suddenly pump the brakes, and then lazily float behind our planet before starting the entire bizarre cycle all over again. Imagine an undercover detective tailing your car on the highway, constantly weaving through lanes and dropping back just to keep you guessing. If you were to map out their intricate path across the sky over many years, the trail paints a colossal U-shaped horseshoe, giving them their fitting moniker. But those are merely the most common cosmic tag-alongs. The solar system is far stranger. Positioned at vast distances ahead of and behind our orbit, there are peculiar celestial wanderers known as Trojans. They do not simply skim along beside our planet the way a typical quasi-moon might. Rather, they have nestled into two incredibly specific, invisible pockets of empty space. One safe haven sits exactly 60 degrees ahead of our path, while the other trails exactly 60 degrees to our rear.
Picture yourself cycling down a long road, flanked by a friend far ahead and another far behind, all of you pedaling at the exact same pace.
This perfectly synchronized escort is exactly how Trojans operate, parked securely inside regions we call Lagrange points.
Think of these points as calm cosmic harbors, where the massive competing gravity of the Sun and Earth cancel each other out in total harmony.
Once an asteroid drifts into one of these serene gravitational pockets, it can comfortably anchor itself there for millions of years without ever wandering off course. The gas giant Jupiter is swarming with thousands of these celestial hitchhikers, whereas our own pale blue dot hosts just a handful. Further adding to the cosmic weirdness are the fascinating tadpole orbiters. Rather than remaining locked perfectly dead center in those safe zones, they playfully drift back and forth in bizarre bean-like patterns. And just when you think you understand it all, the universe throws in jumping Trojans, the most indecisive rocks in the solar system. Refusing to commit to one spot, they might relax in the forward gravitational hammock for a few thousand years, only to slowly migrate across the void to the trailing pocket, bouncing endlessly back and forth through the dark. Bizarre, highly unusual, and honestly, absolutely mind-blowing. Have you ever gazed up at the night sky and thought we only had one solitary companion up there? Think again. Our pale blue dot is secretly dragging around a whole entourage of cosmic hitchhikers. A few dance in dizzying circles, others trail behind like lost puppies, and a handful just lurk in the gravitational shadows. But before we meet the understudies, let us review the heavyweight champion of our night sky. Our primary lunar partner commands the ocean swells, literally pumps the brakes on how fast our globe spins, and keeps our planetary wobble perfectly in check. Erase it from existence, and suddenly our daylight hours would vanish in a flash. Midnight would be pitch black, and summer or winter would flip-flop like a broken thermostat. It also moonlights as a celestial bodyguard, taking the hit for incoming cosmic shrapnel that would otherwise leave nasty scars on our home turf. Beyond the hard science, its grip on humanity is legendary. We have built ancient timepieces around its phases, spun wild folklore about its shadows, and crooned countless romantic ballads under its glow. Throw in endless, moody midnight strolls, and it becomes vividly clear. Those imposter rocks could never hold a candle to the original. That being said, these gravitational groupies still deserve a moment in the spotlight. Every bizarre little companion we discover offers a masterclass in survival, showing us how tiny debris navigates the relentless gravitational tug-of-war in our solar system. Mapping our immediate galactic neighborhood ultimately paints a clearer picture of our own planetary history. Catching these stealthy drifters pushes our telescope technology to the absolute limit and refines the mathematics we use to map the cosmos. Therefore, even if they lack that iconic silvery glow, these hidden companions are vital puzzle pieces in decoding the weird and wonderful dynamics of our stellar backyard. Brace yourselves for a reality check. Humanity's homeworld currently boasts a grand total of 7 lunar companions. And that is just the baseline. There could easily be an entire fleet of them out there waiting to be found. Suddenly, that lonely textbook diagram of the Earth and its solitary satellite feels completely obsolete, right? Imagine the sci-fi possibilities. Does this mean we are destined to build futuristic habitats and launch sprawling colonies across a septet of floating real estate? Could future travel brochures offer luxury zero-gravity getaways to an entire catalog of orbital destinations? Let us pump the brakes for a second, though. These newly discovered sidekicks, dubbed mini-moons, are a completely different breed of celestial beast. Oddly enough, the astronomical rulebook has not quite settled on a strict classification for them yet, because getting brilliant astrophysicists to reach a consensus is practically like herding cats in zero gravity. The working theory, however, paints them as wandering space pebbles that get briefly snared by our world's invisible magnetic lasso. To earn the title, the object must complete a minimum of 1 chaotic lap around our globe, buzzing past us at less than quadruple the distance of our primary lunar neighbor. In layman's terms, if it swoops in close enough to make a stargazer spill their coffee, it makes the list. Our pale blue dot acts like a massive cosmic net, occasionally reeling in these bite-sized satellites. They pull up, crash on our gravitational couch for a spell, and eventually peel off to resume their endless trek around the glowing heart of our solar system. It is a totally random lottery where stray fragments of galactic shrapnel find themselves hijacked by the pull of our home world. They circle our atmosphere for a brief stint, treating Earth like a cheap roadside motel before hitting the cosmic highway once again. Think of it as astronomical speed dating, a fleeting encounter before moving on to the next gravitational match. For decades, the prevailing wisdom pointed to the asteroid belt, that massive junkyard drifting between the red planet and Jupiter, as the birthplace of these temporary tagalongs. However, a handful of fresh observations have completely flipped that old assumption on its head. Prepare to have your mind blown. Some of these transient pebbles appear to be literal shrapnel blasted right off our main lunar companion. A textbook case emerged roughly a decade ago, back in 2016. Stargazers perched atop a Hawaiian observatory noticed a highly suspicious pint-sized anomaly loitering in our orbital neighborhood. Astronomers christened the anomaly Kama'oalewa, a gorgeous moniker that honestly sounds more like an exclusive tropical resort than a chunk of dead rock. In reality, it is a massive boulder roughly 328 feet across, performing a perfect synchronized orbital waltz with our planet around the central star. Subsequent deep dive analysis suggested this jagged runaway likely fractured off the lunar surface anywhere from 1 to 10 million years in the past. That ancient era, long before humanity's dawn, saw a catastrophic collision carve out the infamous Giordano Bruno impact basin, launching this debris into the void. Fast forward to the present day, and the universe has delivered yet another surprise guest. An anomaly officially designated as 2024 PT5. Predictably, its chemical fingerprint is a dead ringer for lunar basalt, rather than your run-of-the-mill deep space rubble. Confronted with this bizarre coincidence, the brilliant minds at the observatories immediately began crunching the complex physics. Enter Robert Jedicke, a heavyweight in the field of orbital mechanics, widely recognized as the ultimate authority on these transient satellites. He and his research squad cranked through countless supercomputer models to calculate the exact odds of lunar shrapnel getting hopelessly trapped in our gravitational web. Have you ever wondered what happens to the cosmic rubble floating past our world? Surprisingly, our planet's gravitational pull acts like a giant invisible net, capturing a lot of this drifting debris, at least temporarily. Astonishingly, roughly 20% of these wandering rocks get trapped to become genuine miniature satellites. Current estimates suggest that right at this moment, half a dozen or so tiny fragments born from our own moon are dancing in orbit around our world. They don't stay bound to us eternally, however. These transient companions are just passing through. A typical mini-moon lingers in our orbital embrace for a mere 9 months before breaking free and journeying back into the cosmic void. Yet because the solar system is a bustling highway with fresh material constantly wandering into our celestial backyard, this rotating cast of tiny satellites is always being replenished. We must admit, though, that these statistics are built on somewhat shaky ground. As researcher Jedicke bluntly put it, the margin of error we are dealing with is absolutely gigantic. When an astronomer uses terms like that, it is basically the academic way of confessing that we are making educated guesses in the dark. There are simply too many missing puzzle pieces, such as the exact magnitude of lunar impacts that create the rubble, the velocities at which these fragments are ejected into the void, and whether our current optical technology is even capable of detecting such minuscule targets. Therefore, our current models could be completely off the mark. But that is the beautiful, messy nature of the scientific process. We formulate a hypothesis. Future discoveries inevitably challenge those assumptions, and step by step, our collective understanding of the universe deepens. Regardless of the exact math, hunting down these miniature satellites is an incredibly frustrating endeavor. Picture an object roughly the size of a compact car or a family SUV, spanning a mere 3 to 7 feet across. That might feel substantial when you are trying to squeeze into a tight parking space. But against the vast empty canvas of the cosmos, it is essentially a microscopic speck of dust. The ultimate hurdle, however, is that their diminutive stature is paired with blistering speeds, rendering them nearly invisible to us. For our telescopes to catch their faint glimmer, they must swoop perilously close to our atmosphere to catch the sun's reflection. But at that intimate proximity, they are tearing across our field of view as if racing against the clock, making it an agonizing challenge to lock onto them, even with the most sophisticated observatory equipment on the planet. This exact elusive nature is precisely what keeps planetary defenders awake at night. What if one of these rogue wanderers decides to plummet directly into our atmosphere instead of merely passing by? We could very well be looking at a terrifying sequel to the infamous Chelyabinsk meteor strike. Picture this. It was an ordinary, peaceful morning in a Russian city, until the sky suddenly tore open. Out of nowhere, an intense burst of illumination flared up, completely blinding the morning sun. That brilliant flash was chased by a catastrophic sonic boom that ripped through the heavens, violently shattering the calm along with thousands of glass windows. This terrifying display of cosmic power unfolded on the 15th of February, 2013. Without a single warning signal, a celestial boulder roughly the dimensions of a multi-story home slammed into our sky, traveling at an astonishing 11 miles per second. Approximately 14 miles above the Earth's surface, the immense atmospheric pressure caused it to detonate mid-flight, unleashing a devastating shockwave of energy. A terrifying shower of shattered glass rained down upon residential streets, classrooms, and workplaces. More than 1,600 individuals suffered injuries, the vast majority wounded by the razor-sharp flying debris. The most chilling part? In the grand scheme of our solar system, this was a mere pebble compared to the monstrous asteroids silently drifting through the dark. Fortunately, experts like Jedicah remind us that today's advanced sky-scanning networks are remarkably adept at detecting these tiny interlopers, even when they are millions of miles away. Yet a significant technological hurdle remains. Because these fragments are hurtling through space at breakneck speeds, they do not register as neat, stationary pinpricks of light in our astronomical photographs. Instead, they smear across the lens as long streaks, and our automated tracking software absolutely despises analyzing streaks. These blurred trails of motion completely confuse the algorithms, allowing these stealthy little moons to slide right past our planetary defenses without raising a single alarm. Thankfully, the narrative of our cosmic neighborhood isn't purely a tale of impending doom. Astronomers proudly highlight that we did successfully intercept one of these elusive travelers, designated as 2020 D3. This discovery was nothing short of a miracle, considering the object was in an observable position for merely 2 evenings out of a staggering 1,000 potential nights. Imagine trying to locate a single needle hidden within a massive haystack, except the haystack is vigorously spinning around in the pitch black. However, the moment we successfully pin down a mini-moon's trajectory, monitoring its journey becomes infinitely simpler. And this is precisely where the future of space exploration ignites. Think about the possibilities. These fleeting visitors might actually hold the key to our next giant leap, as their close proximity makes them incredibly accessible. Launching a mission to intercept one would require a fraction of the fuel and budget needed to journey all the way out to the distant asteroid belt. Because of this, visionary aerospace enterprises are already dreaming of capturing these nearby rocks, transforming them into orbital gold mines to harvest priceless cosmic resources. Have you ever wondered what the smallest celestial wanderers can teach us? From a researcher's perspective, these tiny temporary satellites are an absolute goldmine. They hold the ultimate blueprints to our cosmic neighborhood's initial construction and its ongoing chaotic evolution. By tracking how lunar fragments were violently ejected to become cosmic shrapnel, we gained crucial insights into the sheer devastation a rogue space rock could unleash upon our home planet. Sure, these fleeting visitors whip past us and play an incredible game of cosmic hide and seek, and they might not stick around for long, but they are practically bursting with ancient, universal mysteries waiting to be uncovered. Speaking of lunar companions, picture this. Our world once hosted a pair of permanent, massive satellites, not just passing pebbles. For decades, astronomers scratched their heads over a glaring planetary puzzle.
Why is the Earth-facing hemisphere of our nighttime neighbor relatively flat and polished, while it is almost as if the satellite presents a flawless portrait to us, while hiding a deeply disfigured, camera-shy profile in the pitch black? Well, recent groundbreaking simulations point to a fascinating explanation, suggesting this bizarre asymmetry stems from a sluggish, prehistoric interplanetary collision. Here is how the story unfolds. Eons in the past, a secondary lunar companion glided perfectly in tandem with our primary satellite. For a staggering 80 million years, orbital harmony prevailed. These celestial siblings shared nearly identical compositions and glowing hues, though the primary orb dwarfed its twin by a factor of 3. However, gravitational physics eventually took the wheel. As the pair slowly migrated outward from our world, the immense tug of our local star intervened, violently destabilizing the smaller body's trajectory and sending it on an unavoidable collision course with the hidden hemisphere of its larger sibling. Do not imagine a blockbuster cinematic detonation, though. The impact occurred at an incredibly sluggish, yet relentlessly crushing velocity. It lacked the sheer energy to liquefy stone, acting instead like a colossal cosmic press that molded the smaller sphere onto the larger one like modeling clay. Rather, the doomed twin practically painted itself over the hidden hemisphere, creating the mountainous, uneven crust astronomers observe right now. The aftermath of this merger was an absolute orbital nightmare, launching trillions of tons of pulverized rock into the void. For several volatile days, the immediate vicinity became a swirling maelstrom of jagged shrapnel and cosmic dust. Meanwhile, our home planet endured a relentless bombardment of falling lunar debris that lasted for nearly 1 million years. A handful of those incoming meteors were massive enough to rival the footprints of modern metropolises. Ultimately, the glowing orb illuminating our nights is likely a Frankenstein-esque fusion of two distinct celestial bodies. A beautifully pristine front covers a backside permanently deformed by the crushed remains of its sister. It is a simultaneously heartbreaking and magnificent saga that perfectly justifies why the dark side looks like a battered heavyweight fighter. Imagine looking up at those vast circular scars, almost as if the lunar surface forgot to brace for impact. These are classic impact basins. They exist entirely because rogue space rocks plummeted directly into the crust eons ago. Exactly. Whenever a wandering comet or wayward meteoroid strikes that unprotected terrain, a massive bowl-shaped depression is born. The sheer number of these scars tells a violent history. Yet there is one particular indentation with an entirely unique origin story. The prevailing scientific consensus suggests our entire satellite was birthed from a cataclysmic impact, mirroring the violent creation of those surface scars. However, that foundational planetary strike was unimaginably more ferocious. Picture a timeline stretching back more than 4.5 billion years, when a colossal Mars-sized rogue world named Theia obliterated early Earth. Over time, gravity gracefully sculpted that chaotic ring of destruction into the glowing sphere we recognize today. In the immediate aftermath of its fiery birth, our new companion was nothing more than an inferno of boiling magma, hovering dangerously close to our world. Intense tidal friction mercilessly meted the molten sphere, dialing up its internal temperature even further. Eventual cooling forged a solid outer shell. But let us fast forward to the real cosmic drama. Picture a space rock massive enough to cover the entire nation of Nepal, dwarfing the impactor that doomed Earth's dinosaurs, violently striking the hidden face of our lunar neighbor roughly 4,300,000,000 years in the past. This spanning an immense 1,500 miles across. This void plunges an astonishing 5 miles into the lunar crust. To put that sheer scale into perspective, you could drive from New York to Dallas across its width, and its depth could comfortably swallow Mount Everest whole. What makes this fascinating is that researchers suspect this colossal strike excavated and violently expelled incredibly old matter hidden far beneath the surface. We call this unique blend of substances by a catchy nickname, CREEP, standing for potassium, rare earth elements, and phosphorus.
These minerals act as a chemical window, looking back into an era when our moon was nothing but a bubbling sea of magma.
So, what makes this desolate stretch of lunar real estate suddenly the most thrilling puzzle in modern astronomy?
For decades, the reigning scientific consensus assumed that the cosmic projectile struck from a southern trajectory, gouging its way north, which supposedly blasted a massive spray of radioactive debris, pushing all those precious creep deposits straight toward the northern boundaries of the impact zone. However, fresh analysis has completely flipped the script, revealing the meteor actually hurtled in from the northern skies. Consequently, those priceless subterranean materials were actually flung to the southern rim. And here is the ultimate twist. The upcoming Artemis 3 lunar landing by NASA is aiming directly for that exact southern territory. Astrophysicists first began doubting the original Southern Strike model by analyzing similar collision scars scattered throughout our cosmic neighborhood. They specifically looked at the Hellas impact zone on Mars, alongside the icy Sputnik crater located on Pluto.
Take a look at these planetary formations side by side. Notice how every single one shares a distinct avocado-like silhouette, featuring a broad base that tapers off into a sharp tip.
In orbital mechanics, that tapered end functions like a giant cosmic arrow, pointing directly toward the origin path of the incoming space rock. Applying this logic to the massive lunar scar, the evidence clearly dictates a northern entry vector, entirely disproving the southern approach theory.
Seeking concrete proof, planetary geologists resurrected archival telemetry from a legendary NASA probe called Lunar Prospector. This robotic explorer circled our celestial neighbor between the years 1998 and 1999.
During its flight, the satellite scanned the lunar landscape for radiation signatures, uncovering massive spikes of thorium,
A crucial ingredient of creep, heavily concentrated along the southwestern border of the crater. This brings us to Artemis 3, an incredibly ambitious initiative designed by NASA to return human boots to the lunar dust for the very first time since 1972. Assuming the mission timeline holds steady against complex engineering challenges, blastoff is penciled in for mid-2027, immediately following the completion of its predecessor flight. You see, the second Artemis voyage, slated to leave Earth before April 2026, serves as a high-stakes practice run where a human crew will circle our lunar companion without touching down, verifying every piece of hardware performs flawlessly. Consider it the ultimate test drive through the vacuum of space. But the third expedition is when history will truly be rewritten. Explorers are aiming to touch down near the lunar South Pole, selecting from 9 carefully mapped drop zones chosen by space agency engineers. The major hurdle right now is the ticking clock, as both of these upcoming manned missions have faced significant scheduling setbacks. We kicked this new era off back in 2022 with the first Artemis launch. That inaugural flight carried no passengers, serving merely as a robotic proof of concept that successfully looped around the moon and safely returned to Earth. Therefore, the next stepping stone is launching actual people deeper into the cosmos, paving the way for the monumental third mission. These brave pioneers will spend approximately 7 days traversing the extraterrestrial terrain, conducting groundbreaking research before igniting their engines for the journey home. Looking further ahead to the 4th and 5th installments of the program, the goal shifts toward constructing a brand new compact orbital outpost circling the moon, appropriately named the Gateway. Imagine a futuristic truck stop suspended in the cosmic void. Spacefarers will be able to moor their ships at this hub, reside there during temporary deployments, run scientific trials, and stage their descent to the surface below. This orbital base camp is a massive collaborative effort, bridging American aerospace ingenuity with essential contributions from European, Japanese, and various other international space agencies. Our next batch of cosmic explorers will be riding aboard the Orion capsule, hurled into the void by NASA's monstrous Space Launch System. Picture a mechanical beast towering over the Statue of Liberty, packing enough raw thrust to catapult human beings all the way to lunar orbit. But reaching orbit is only half the battle. Touching down requires a highly specialized human landing module. Assuming it aces its safety trials, the colossal SpaceX Starship will serve as our ultimate ferry to the dusty lunar ground. Yet, our celestial neighbor is merely a stepping stone in NASA's grand vision. The ultimate prize? A sprawling bridge from the moon to the red planet. The dream is to treat the Artemis missions as a cosmic training ground, erecting a lunar outpost that paves the way for humanity's monumental trek to Mars. But have you ever wondered what else awaits us up in the dark? Once our boots finally crunch on the lunar regolith, we might just crack one of astronomy's most puzzling cold cases. For centuries, stargazers have witnessed phantom glows, sudden flashes, and bizarre beams of light dancing across the face of our rocky companion. So, what exactly is painting the dark side of the moon with these ghostly illuminations? Let's dive right into the cosmic shadows. The story kicks off on April 19, 1787, when the legendary astronomer William Herschel caught sight of an absolute anomaly. Deep in the unlit portion of a new moon, a blazing beacon flared up, burning brightly for hours and rivaling the intensity of the Orion Nebula itself. Today's astrophysicists believe Herschel was witnessing what is formally known as a transient lunar phenomenon. We call them TLPs for short, and they are essentially brief, enigmatic bursts of light or sudden chromatic shifts dotting the lunar landscape. Sometimes they manifest as radiant patches, while other times they bleed into deep crimson or vibrant violet stains. They can even mimic ghostly fog-like clouds that blink into existence and vanish just as swiftly. If you dig through the historical archives spanning the past 2 millennia, you will find roughly 3,000 documented accounts of these bizarre lunar winks. Stargazers have captured them through early spyglasses, modern telephoto lenses, or sometimes just by staring up on a clear, dark night. Which begs the ultimate question: what invisible forces are triggering this extraterrestrial light show? Truthfully, there is no single smoking gun. The culprits range from violently colliding space debris to subterranean gas eruptions, or perhaps even wild static discharges. A single event might wink out in a fraction of a heartbeat, or burn steadily for half the night. And that exact duration acts like a fingerprint, giving researchers a crucial hint to unmasking the origin of each specific spectacle. For instance, those microscopic blinks vanishing in under 60 seconds, those are almost certainly the explosive signatures of rogue micrometeorites slamming into the crust. Imagine a stray piece of space rubble weighing no more than an 8-ball, hurtling through the vacuum. When it strikes the airless terrain at hypervelocity, it releases enough kinetic energy to ignite a momentary blinding flash. The sheer friction superheats the crushed rock into a brilliant glow, which then rapidly plunges back into darkness as the vacuum steals its heat. Decades passed with astrophysicists harboring strong suspicions that these microflashes were born from cosmic collisions. Yet the ultimate proof remained hidden until the 1990s, when ultra-fast photographic technology finally revolutionized our astronomical toolkits. Still, separating fact from fiction was a monumental headache. A tiny blip on a monitor could easily be written off as a digital artifact or a random spike in electrical interference. To eliminate all doubt, astronomers had to triangulate the exact same spark using multiple observatories simultaneously. The stars finally aligned during the spectacular Leonid meteor storm of 1999. Researchers triumphantly captured synchronized footage, proving beyond a shadow of a doubt that these were genuine kinetic impacts. As our tracking improved, it became glaringly obvious that our orbital neighbor acts as a constant cosmic punching bag. Interestingly, these luminous hits often appeared clumped together in specific regions, such as the vast Oceanus Procellarum. If you have ever gazed at the moon, that is the sprawling, charcoal-colored basin dominating its western edge. However, this apparent clustering was largely an optical illusion born from where astronomers happened to be pointing their lenses. A comprehensive study published in 2024 ultimately revealed that this celestial shrapnel bombards the entire lunar globe with equal prejudice. But what about the eerie illuminations that linger for several minutes? Those point to an entirely different beast, like primordial gases bleeding out from the moon's deep interior. Research papers from 2008 and 2009 uncovered that volatile elements, particularly radon, can accumulate beneath the crust before violently venting into space. And honestly, we all know the sheer relief of letting out a little built-up internal gas, right? As this radioactive vapor breaches the surface and begins to decay, it emits a subtle, ghostly luminescence that manages to travel all the way to our earthly telescopes. Fascinatingly enough, these radiant exhalations match up perfectly with orbital maps where geologists had already pinpointed massive underground radon pockets. But what about those eerie illuminations that linger out there in the void? They burned steadily for hours, identical to the mysterious phantom glow William Herschel documented way back in 1787. A massive 2012 research paper pitched a wild idea, pointing the finger at solar wind,
which is basically a relentless blizzard of electrified particles blowing off our sun. Whenever this cosmic storm slams into the powdery lunar soil, it statically charges every single speck of dirt. Suddenly, all that dust blasts upward into the vacuum of space, building towering columns over 60 meters tall. These suspended cosmic fogs act like giant funhouse mirrors, catching and bending the scattered light from distant planetary bodies and stars.
The result is a mind-bending optical illusion where the entire lunar surface appears to be radiating its own internal fire. A beautiful puzzle we desperately want to solve.
Once humanity touches down again with the Artemis program, we are going to start cracking these ancient riddles wide open. Honestly, the anticipation is absolutely electrifying. Now, picture standing up there while the rock beneath your space boots suddenly begins to violently throb. Every instinct in your mind screams that you are in deep trouble. You always assumed our orbital neighbor was a frozen, dead wasteland, right until everything freezes for a split second. Then, a massive shock wave rips through the crust and throws you flat on your back, leaving you wondering if a literal moonquake just hit. For generations, the scientific community swore up and down that our lunar companion was completely geologically dead. However, groundbreaking new clues are totally flipping that old narrative on its head. Over at the University of Maryland, eagle-eyed experts recently mapped out 266 bizarre wrinkly formations hiding out on the dark side of the moon. These weird geological scars are massive red flags screaming that something is still moving down deep in the crust. Does that mean the ground is genuinely shaking up there? Well, it is complicated, but absolutely. You will find these wrinkled zones clustered around ancient magma fields that cooled off roughly 3.2 to 3.6 billion years in the past. Yet, they look incredibly fresh compared to the surrounding wasteland, usually grouping together in packs of 10 to 40 distinct formations. They tend to pop up exactly where the lunar crust is brittle, fragile, and ready to crack under pressure. Before you panic, remember that when an astrophysicist says something happened recently, they are speaking a completely different language. We are definitely not talking about last Thursday, or even when your great-grandparents were born. Classic textbook computer models insisted that the lunar core flatlined somewhere between 2.5 to 3 billion years ago. Yet, this fresh pile of data suggests these cracked landscapes might have been shifting around within the last billion trips around the sun. Digging even deeper, a handful of the tiniest wrinkles look incredibly new. They might have ripped open a mere 200 million years ago, which is basically yesterday when you are looking at a cosmic calendar. That implies our supposedly dead satellite is still actively breathing, stretching, and transforming right over our heads. Unearthing this forces us to throw out decades of accepted theories.
It completely rewrites the entire biography of our closest celestial neighbor. But how exactly did the experts piece this puzzle together in the first place? A brilliant team joining forces from the University of Maryland and the legendary Smithsonian Institution tackled the problem.
They relied on a clever cosmic forensics technique known as crater counting to figure out exactly how old these wrinkles were. The logic is actually beautifully simple once you wrap your head around it. Think of craters like dents on a car. A smooth patch means fresh metal, while a heavily battered zone has obviously been parked out in the cosmic hail for eons. Taking a closer look, the team noticed these new rocky wrinkles literally slice straight across pre-existing impact craters. That tells us these scars are late arrivals, probably ripping through the crust roughly 160 million years back. When you measure things by the lifespan of planets, that is so incredibly fresh it might as well be happening right now. It practically guarantees the intense forces building these craggy mountains are still rumbling away in the dark. What is even more fascinating is that the stretch marks facing Earth perfectly match the ones hiding on the far side. That undeniable similarity tells us the exact same underground machinery is driving the chaos everywhere. A universal set of invisible hands is actively sculpting the entire sphere all at once. We are talking about epic, slow-motion violence like the entire moon shivering, physically shrinking down like a dried-out raisin and getting stretched by orbital gravity. We are definitely going to dive deeper into that mechanical nightmare a little later on.
Want the ultimate proof that our skyrock is still kicking? Just dust off the forgotten recordings from the Apollo era.
Those legendary astronauts actually planted sensors that picked up shallow, rattling tremors decades before we ever fully understood what they meant.
Have you ever wondered if the ground beneath an astronaut's boots could suddenly, violently tear open? Instruments left up there actually caught 28 distinct tremors, clocking in anywhere between a mild 1.5 and a pretty solid 5 on the Richter scale. Those strange buckled scars streaking across the lunar crust? Experts are convinced they serve as the direct fingerprint of this exact underground trembling. But here is the real cosmic plot twist. Our glowing neighbor in the night sky is literally shriveling up like an old apple. To understand why, we have to rewind 4.5 billion years, back to when a rogue planet, roughly the bulk of Mars, violently slammed into a young, chaotic Earth. That apocalyptic crash blasted colossal waves of boiling, glowing rubble straight out into the freezing void, where it slowly gathered together to form the glowing orb we know today. Back then, our newborn satellite was nothing but an endless, roiling ocean of liquid magma. It violently heaved and cracked, constantly tortured by apocalyptic eruptions and deep internal quakes. Picture a colossal drop of glowing lava, just adrift in the pitch black of the cosmos. So, when exactly did this furious ball of fire finally freeze into solid rock? Astrophysicists recently cracked the code. The grand freeze happened precisely 4.43 billion years in the past. That moment changed the course of cosmic history, entirely rewriting the destiny of both our world and its new companion. In fact, that colossal collision might have been the ultimate reset button, calming our home planet down just enough to eventually cradle living things. Fast forward through eons of silent cosmic history. The fiery sphere chilled and shrank, ultimately morphing into the familiar silver globe that watches over us after dusk. Yet do not let its quiet face fool you. Deep down, it is not totally frozen solid, and the chilling process is happening right now. That relentless, agonizingly slow loss of core heat is likely the invisible engine driving those surprise moonquakes today. Imagine a hot cake coming out of the oven. As the temperature drops, the moon's inner guts physically pull inward. This forces the brittle outer shell to snap and buckle, leaving undeniable evidence scattered across the vast lunar plains. You know those massive, shadowy stains you can see whenever you look up at night? Astronomers call them Maria, immense basins where prehistoric space rocks smashed the crust, allowing floods of magma to bleed out and eventually harden into flat plains. As the globe shriveled up over the millennia, it pushed that hardened crust into sprawling vein-like folds across the terrain. But the plot thickens. Our own world's massive gravitational pull might also be playing a huge role in this alien geology. Earth constantly tugs and stretches its companion, generating immense friction and pressure within the lunar rocks. This cosmic tug-of-war is powerful enough to snap the surface and unleash deep structural shifts. Fascinating science, right? But here is the ultimate question. Does a shaking lunar crust actually matter to us down here on Earth? Surprisingly, the answer is a resounding yes. For decades, we pictured the lunar surface as a dead, quiet sanctuary, the perfect, peaceful real estate for mining colonies and astronaut habitats. Finding out that the ground can violently betray us completely shatters that illusion and throws a wrench into our plans. A sudden fault line snap could effortlessly tear apart expensive habitats, collapse vital tunnels, or completely ruin delicate drilling equipment. Because of this hidden danger, deploying high-tech vibration sensors and deep scanning radar systems is absolutely critical right now. We essentially need to map out the moon's temper tantrums before we set up camp. Doing this homework lets us pinpoint the safest zones, ensuring a sudden tremor does not turn our next giant leap into a disaster. And as if invisible earthquakes were not enough, there is another completely different nightmare waiting for the next generation of space explorers. Enter the microscopic villain of the cosmos, lunar regolith, or as we call it, moon dust. The pioneers of the